signal. Good. Someone else is taking off the responsibility of breaking things. I have plausible deniability. What'd you do? Oh, I didn't think it was behind the mask. Yeah. So he shit and stuff and things. Is that what he did?
The projector was off.
So that power, oh, it was the wrong color light.
Fans are for off projectors when they're cooling.
They should be fanned all the time.
Right, but I think since the fan was on, we thought the projector was on.
Exactly. The power light was on and the projector fan was running, but the power light was orange and not green.
Okay, we're looking for a meeting, a note taker. We'll wait for people to trickle in.
Hey, I know that dude.
Anybody interested in taking notes? You don't have to be in the room. You can be in the room. Who wants to be a note taker? Note taking is an excellent opportunity to to now be part of the process. Anyone online who wants to be a note taker? It will give you a great sense of participation. You can, if you'd like to. You'd be more than welcome.
How do I take notes in my own presentation?
Somebody else can do it when you're up. We can. Does that sound like Eric? You're interested?
It's a once in a lifetime opportunity.
Yes, go to Meet Echo, and there is a note-taking tool. Yes. Try the click on the video.
Maybe in case no one else does it.
All right, we'll try and find somebody.
Sewing, because I definitely want to prep for myself.
I got you.
But I will. I won't leave you hanging.
Let me see here.
How about if you take notes, I'll take notes while you're presenting.
He's
Say you're doing that.
he said try to find somebody else.
Oh, overall.
Okay. And use you as a backup. Hold on a second. Let me see if there's one person. But,
People walking around, look around, run away. No. All right.
Does multicast have light? Yeah, where's the question?
Yeah, we're here. We're here. Not dead yet. Here we go. I want to take a walk.
Jake, would you have any interest in being the note taker?
Sure, I can do that.
And when you're up talking, Eric
So
can take the reins.
All right. I think Max is mostly driving our slide.
Okay.
Oh, excellent.
All right, cool.
So
Even better.
Yeah.
Yeah, we're good. Okay, we'll wait another minute for people to come back from lunch.
Wake up from the food coma.
Switch to the, go back to the, I'm less familiar with that interface. That's
Yeah,
the
that looks like
online
the
tool.
remote interface.
Do the remote one. I'm sorry. Click on the
Just a video
video link,
from the agenda.
Yeah,
video stream,
running agenda. Yep.
and you should get an interface that looks like this.
And then on that, the little box with the pencil sticking out, that's the note taking tool.
Video stream. Cookies, go. No.
You gonna show me what you got? I'll show you.
Loading.
Okay. Yep, you're good. And it's an online note-taking thing, so you and Jake can work in tandem if he gets up. Okay, are we ready to get started?
I'm about as ready as I can get.
Okay,
How's the room? You guys ready?
all right.
Look at that enthusiasm. The energy is just overwhelming. There we go. We got one yeehaw.
All right. So we're gonna,
Plow right through this food coma.
all right, we're gonna start taking off for this flight. Here's the note well. It should bear a striking resemblance to all the other note wells you've seen at the beginning of every meeting. Just please read it and be aware of what's what is noted well in participating. Meeting tips. For those who are just arriving today and haven't been in any of these previous meetings, even if you're in the room, please do join the Meet Echo tool because that acts as the blue sheets. And it also enables you to participate in chat and any polls that we have. Just a reminder, please wear your masks unless you are actively speaking at the mic and you think that that can help be a little more clear. And remote participants, keep your audio and video off unless you are presenting. Here's today's agenda. We have a action-packed agenda. Let me know if we missed anything or if you'd like to bash this agenda. Otherwise, this is the plan. Actually, Warren was supposed to be here. Is Warren in here? Warren with a W. Okay. Yes, we missed Warren. All right. Yeah. Is there any other ops area meetings going on right now?
I guess we'll just cut him in if he shows up.
Yeah, he must be DNS ops. I guess we know where we fall in his hierarchy of interests. Or he's still at lunch.
Well, there's only one of them. We can't wrap up.
All right, so status of working group docs. Yang models document. Sandy, are you on? And Sandy, would you like to speak up about do you have any updates or anything you'd like to say about the Yang models draft? Sandy, are you there? I see you in the, yeah. Okay, Sandy, let us know if you have, if you want to jump up. The telemetry draft, how you will be presenting on this. And
Okay, she said in text, Dan Craft should like to ask for more review.
okay. Yeah, so been a pretty consistent thing. So please do, if you're interested, if you have interested in passions in Yang, or even if you don't, um, that's a draft that's been sitting for a while and needing comments. So please speak up, so please take a look at it, review it, and reach out to the authors with any comments you might have. The redundant ingress failover draft, this has been adopted since the last, since Vienna. So that's a new working group document. Do we have any authors, co-authors want to speak up and say, have anything to note about that draft, any updates, or is it just the same as from when it was originally submitted? Anyone? No? Okay,
She's sending her message in the chat. She won't be speaking. It's midnight there.
gotcha. Is Sandy a co-author on that one?
On
Are you a co-author on that one?
I am too.
Okay. Do you have any comments about that one?
Other than that,
Here.
review. I owe them a review.
Okay. Jake, do you want to come up and give us an update on your multicast to the browser drafts? The dorms, AMB, CBAC, and MNet. I should note, dorms just went working group last call. We've heard some comments. I would encourage others. Please speak up on list if you want to see this document advanced to IESG.
Does that work? Yeah. Thanks, Lenny. This is Jake. So most of my time since 113, as I mentioned there, was on the quick work. So I did like do my own self-review of dorms before poking you about last call, and I think it's okay. So yeah, I'd love to see it go forward. Probably next on my list is MNet. And after a round of reviews, and I kind of, because there's a dependency on dorms, I want Ambi and CBAC, to make sure that those are going to be unimpacted by any feedback I get on dorms. But I will want to get reviews on those from security people and transport people, respectively, at some point. But that'll be coming up soon. Well, soonish, I hope. Maybe, especially MNet. I think there's been a number of networks that wanted to use that, so I'll probably want to push that forward, and then CBAC probably more than Ambi, because for the endpoint authentication, Quick will also cover that. So Ambi might turn into just a sort of forwarding for the network, which is still important, but probably not as important as the endpoint when I thought it was going to be using that. So yeah, so these are still I intend to get them over the line one day. Thank you.
Talk about the clustering. Are all three,
Oh, yeah.
four being clustered, and do you have to cluster them at the same time? Like, how do we?
Yeah, so
how is it
I
that
actually asked the RC
dorms-
editors this earlier this week. So they get auto clustered apparently when they reach the if there's normative references between them, when they reach the RC editors queue. But I can also just send a note and ask them to the RC editors. So I might do that. MNet is not part of the same cluster. I just have a cluster, or I just wanted a cluster for dorms, ambient, CBAC, because they're all part of the same protocol, basically. All right. Yeah, thanks.
Great, thanks. So again, we encourage everybody take a look at speak up on dorms and take a look at and review Ambien CBAC, so we can work on advancing those as well soon. And those are all the active working group documents. So we'll move on. So Warren was supposed to be here, and I believe, if I might steal his thunder, I think he was saying that his term as AD is expiring soon, and he wanted to encourage others to consider becoming an AD. If you're interested in becoming an AD and being his successor, and have questions about that, please do reach out to him. And if he does come in, we'll see if that's what he says. So next up is the telemetry draft. How you? Right.
Hello everyone, this is how you move from Future.
Yeah, is that on?
Oh, okay. Yeah, this is Hao Song from Future Way. Today I'm going to give you a brief updates and recap of this unpassed telemetry using IOM for multicast. On behalf of our co-authors. Next slide, please. So first, updates of this new revision. We actually several technologies this document is based on have been go through the some of them has been published as RFC, and some of them is on in the last stage for publication. So now is a good time to make sure our scheme is actually comply with the existing standards. So, for example, this scheme is based on, one of them is based on the IOM trace option, which already been specified in RFC 9197. And another option scheme is based on the IOM direct export draft that will be published soon. Okay, next slide. First, the problem we want to solve in this draft is to apply the unpassed telemetry technologies for multicast. We think it's useful to monitor the multicast traffic. So the so-called unpassed telemetry means we insert the instruction and the telemetry data in user packet itself. So by doing that, we can collect the real-time performance and the experience of user traffic. And it's also very useful in terms of multicast. It can help us to reconstruct the multicast tree from the data trace we collected. But the issue about that is if we just use IOM trace option, it will introduce considerable data redundancy. Because each destination node will collect the trees of the entire path. You can imagine in this tree, many sections actually are overlapped from the root to each node. But if you get all those data and all the leaf nodes, that will there will be a lot of data redundancy. We want to avoid that. So we can have two solutions to solve this problem. The first one is still based on the IOM trace option. The second one is based on the IOM direct export option. Next slide, please. So for the trace option means we just keep adding the telemetry data in the user packet on the forwarding path. So you can see this why it will introduce a lot of redundant data in the multicast tree. So the solution is we basically combine the IOM trace option and the postcard-based telemetry. We don't try to collect the data trees for the entire path. Actually, at each branching node, we just configure the node to export the data we collected so far. Then we clear the trace and then on each branch, we can do the data collection again. This option, there's no need to update the RFC 9197. It only requires the data plane configuration. Next slide, please. So this is a figure to show show an example. You can see this multicast tree, and to node B there will be 2 branches, and node D there will be 3 branches. Then we configure the node B and the D to let them know. And at this point, you need to just export the data collected so far. Then we can clear the data part. Then we can start over again on each branches. And but to reconstruct the multicast tree, we do require that the node ID data is mandatory, that must be collected. And also, so each section's trees also need to include the branching node. For example, the node D, it export the data must start from node B. So it covers the section B, C, and D in this example. Next slide. The second optional solution is to use the IOM DEX as a direct export option. So for this, each packet only carry an instruction header to tell you what data to collect. And then each node will just send an independent postcard packet to send the collected data to some collectors. So therefore, the data never goes with the user packet. So there will be no redundant data because each node will only export its local data. But the issue here is that in the case of a multicast, for the postcard mode, we need to correlate the postcard data. This is especially challenging for multicast because we also need to identify which branch this data is postcard data comes from. So to solve that problem, we need a new data type. We call that branch ID or branch identifier. Solution, the branch identifier contains 2 parts. The first part is a node ID. This is identical as specified in RFC 9197. It uses 3 bytes to hold the node ID. Then we use 1 more byte to hold the branch index. So this is a local assigned index for each output port of the multicast tree. So therefore, we can support up to 256 local branches. So by combining the node ID and the branch index, we can uniquely identify each branch and each branching node. Next slide, please. So left side, you can show some frame format of this direct export instruction header. We will need to allocate a flag bit, we call that M, to indicate this is for the multicast use case. So if the M bit is set to 1, it means there will be an optional data field, multicast branch ID, included in the data part. You can see there's a third optional part, which includes the branch ID we just introduced. So with such information, it allows us to easily reconstruct the multicast tree. On the right side, you can see an example. In the bracket, it just means the branch ID. You can see in the node A, the postcard send packet includes the A0 as a node ID. branch ID and followed with telemetry data collected at node A. And at node B, it sends the branch ID A0, then the local data collected. But you can see in the following node, there are two branches. The upper branch will with the branch identified B0, and the lower branch will have the branch ID B1. So with this information, it allow us to easily identify where this postcard comes from. Then we can easily reconstruct the multicast tree. Next slide, please. Okay, so this is a brief introduction about this, and so far we think this document is already pretty mature, and therefore we ask the working group to consider the working group last call for it. Thank you. Any questions?
I think you can just walk up there. It's a small enough room, we can manage.
Yeah, Jake Holland. Do you have any implementation status to share on this work? It looks pretty good, I think.
We don't have an implementation for this multicast yet, but we do have a implementation for the IOM in general.
And is that in what, the Open Daylight or in?
It's in the, I think in the product. Yeah.
Okay, great, thank you. And what was the other? I haven't looked at the latest version of the draft. Do you talk about the index stability when interfaces come up and down, like when new interfaces are added?
Mm-hmm.
And is it relative to the current fan-out tree or to the interfaces that are available, or like how are the local indices assigned? If you could speak to that a little bit, or just tell me to read the draft if it's all spelled out there.
I'm not sure I understand your question. You're talking about the interface up and down.
So the branch ID, as I understood it, in the DEX version, is a local interface identifier of some sort. Is that correct?
Yeah, we locally assign ID for each interface, so we can just use the 1 byte value attached to the node ID to identify the unique branch. Yeah.
And then as it changes while flows are in progress, are you speccing out how the IDs change or how to reaggregate those?
Basically, I expected that it can be static because it doesn't matter. The only use of it is to help us to reconstruct the multicast tree. So because we also have the node ID in it, so as long as we can distinguish the different branches, that's a
okay. So you see this as a static assignment on an interface, essentially.
Yes,
okay, great, thank you.
Niels Warnke, Deutsche Telekom. Basically, Jake, you asked half of my question as well. So when I was looking at the data scheme that you provided, I think 2 or 3 slides back, my question is, are you actually distinguishing which interface receives or sends the multicast on the node, or is this purely monitoring of the node ID as such?
It's the node ID data is already available to be included. So, but if we think about the multicast case, if there's no branch ID, then, for example, the next node from the branching point, they both send a postcard packet. Then you will not know. You cannot tell if they are belong to the different branches or
correct.
So with that information you can tell. Yeah.
So rephrasing my question, I have 2,000 multicast streams in my network, and I have a router, a P router in my network, which has 350 multicast activated interfaces.
Okay.
How many postcards will I receive?
Oh, so each tree you might be able to aggregate that explore data, but it's easy to distinguish the different multicast tree because in addition to this branch ID, we also have the flow ID and I forgot in the figure we have some other information to tell you which flow it belongs to. So you can easily attribute the data to different multicast tree. They will not mix together.
So the Lenny, could you go back 1 or 2 slides, please?
Excuse me.
No, Lenny.
Mm.
Yeah,
The next
this one exactly.
Yeah, flow ID and the sequence number. Yeah, flow ID basically tell you it's a unique number and tell you
That's a multicast stream, right?
yeah.
The S comma G. Okay.
Sequence number tell you the order of this this packet.
And where in this information do I find the interface to reconstruct the tree? Or is this not included in the postcard?
This is a come from the every packet. Then and each node will assign that writes that part. That's the multicast branch ID. Because I just need to use that information to tell to reconstruct the tree.
Okay, so the flow ID is corresponding to the multicast group.
Oh yeah,
And
flow
the-
ID never change.
yeah.
It's start from the source and
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 so-
also the sequence number never
and-
change. Yeah.
And the multicast branch ID reflects then the interface ID.
Yeah.
Is that what you're saying?
Yeah.
Okay, so back to my original scaling, if you have 350 interfaces, you would receive 350 postcards from one router, right?
One router, I said, based on the current scheme, is support up to 256 different branches.
Oh, yeah. Okay,
Yeah.
so that was exactly where I was pointing at.
Mhm.
So 256, I don't know, for a large IPTV, that is already narrow. Huh? On our P routers, for example, we have more than that. But on the other hand, it's a good start and a good approach. What I would just like to point out is that the interface is really key and needs to be included in this postcard, because otherwise you will have hard time because of the sheer amount of postcards that you will
Yeah,
receive.
yeah. So you think that 8 bits is too few?
I can only say for us it wouldn't be enough, but I don't know if this is really representative of IETF or operators. Yeah.
Yeah. So okay.
Thank you.
Thank you.
Dino?
This is Dino. Thanks for the presentation. I just wanted to say I support the idea of wanting to solve multicast telemetry. At the Olympics, they want the U.S. broadcaster wants to look at data on the tree, both downstream and upstream. And what we did in Tokyo is we used the Lisp control plane to find out things like RTT times on each branch, one-way hop count, forward and reverse, latency forward and reverse. The advantage we had with doing it with an overlay is that we didn't have to touch the underlay routes at all, and we were still able to get that granularity of information. And I was thinking maybe I'll present that next time at the next Mboned if you want.
Yeah. Thank you.
But I definitely for solving this problem.
All right, so just a quick show of hands. Who has read this draft thus far? Yeah, if you could use the tool. The question to the crowd is who has actually read the draft? You can.
Yeah, it's a short draft. Can finish it very soon.
I
The most important thing if you have, please raise your hand. If you haven't, you can either abstain or not raise your hand. We can do the math. All right, so it sounds like there's a lot of interest. Just needing more folks to read the draft, so please do take a look.
Thank you.
Okay, Jake, you're up. Or no, I'm sorry, Max. Max, you're up. Get your slides. I'm going to bring your slides up.
There we go. The poll is still up.
How do I slide view?
All right. Hello, everyone. I'm Max from TU Berlin, and I'm presenting the multicast quick extension. Yeah, Jake presented it already at Quick just before lunch, and now I'm going to present it to you. So let's start with the basic idea. Next slide. But yeah, the idea is that we still want to get multicast into the browser, basically, and we're looking for ways to do that. And since browsers have quick implementations, we thought one way to do that would be to use those quick implementations to find a way to get multicast into that. So what this extension does, it basically uses a quick unicast connection as a sort of anchor or side channel from where the client starts, and it can say, the client can say, I support multicast, and these are my limits, basically, like this is my maximum supported rate, etc. And then the server could tell the client over the unicast connection some multicast channels, basically, and tell the client to join these multicast channels to receive data. So it's server driven. The server picks which SSM, we only support SSM channels the client should join. The client can then decide, okay, I'm going to try to join these SSM channels. And on these SSM channels, the client will find quick frames, quick packets, which contain data, basically. If the client is unable to join these channels, the server could then decide to also send the data over the regular unicast connection, which means that the client, so no matter if multicast is supported or not, the client would still get the data. The idea is also that it's transparent to the overlying applications. Of course, they would have to set a flag to support multicast, because obviously for some applications you don't want multicast, but from that point on, it would just see normal quick data arrive basically on connection. Okay, so what Quick also gives us is a way to encrypt and use integrity. So each packet, no matter if it's sent on the multicast channel or the regular connection, is encrypted. Obviously, the issue is that every receiver gets the same packet over the multicast channel, so it's not a high bar to decrypt because the key is sent to everyone, the same key. So that alone isn't enough to guarantee integrity. So we also send integrity frames, which are basically hashes for each packet that guarantee that when the receiver sees a packet over the multicast, it knows that it's a valid packet. Right. So the client also acts the packet it receives, the packets it receives over the multicast channels over unicast. So the server knows which packets arrive, which packets get lost. So in that way we have reliability. And the flow control and congestion control are obviously different. So as I said before, the client sets its own limits. And that's the way congestion control is done. Of course, the server could also do something, if it sees that a lot of packets get dropped because it doesn't receive the X, then it could also tell the client to leave some channels. Right, it only works from server to client, so obviously the client can't send multicast. And Dino, sure.
Yeah, I just want to ask a clarification
Yep.
question, and it only requires a yes or no answer, I think. But could I change the terminology just so we're on the same page? When you say server, we mean source. When you say
Source,
client,
yes.
we mean receiver joining the group.
Yes,
Is that right?
yes,
Okay,
right,
great.
right.
So what if you're a source and I'm a receiver? What if I want to join the group, but you haven't opened the unicast connection to me? That means I can't join it. Is that true? So you have control of the source of who joins. Is that kind of the architecture?
Well, you don't have control of who joins, right? Anybody could join send an IGMP. You're still underlying that you system.
Will they get the data if they do that?
They will get the data, but they can't necessarily decrypt it or check the integrity.
So it's not useful then?
Well, but again, the key is shared with everyone, right? So like a bad actor could
No,
give the key.
it's fine. I just want to know what the trade-offs were in the architecture. And so that means you're actually putting some access control. This is really a source-initiated multicast communication, and the source really has control of who joins the group.
Yes,
Okay,
essentially. Yeah.
sounds good.
Okay.
Well,
Yeah.
I shouldn't have said sounds good, but okay.
Okay. Yeah. Okay. Right. As I said, the packets arriving over multicast are for the application. They don't differentiate. Yes, Jake.
Yeah, again, just to clarify, from a multicast channel perspective, you're right, there's a source and a receiver. But since this is like maintained as part of a quick connection, this is why we chose the terminology server and client. It's in the quick context that we have a server and a client. And in that context, it's sort of incidental that they happen to also be source and receiver for multicast. They don't have to be.
A multicast source could be somewhere else and be controlled by the server with unicast quick connections.
Please repeat the question on the mic. If you can, or Jake, just repeat his question for him.
That was a really interesting comment. So can you have the server do the unicast control plane with the receivers and the source be some other node on the network?
Yes, that's going to be common, we expect, for truly scalable solutions. Yeah, because you're going to need to anchor it with a unicast connection.
Yeah, Kyle Rose. I mean, I think one of the important things about this this proposal is that it's not a general multicast mechanism. It's intended specifically for the case in which you already have a relationship with a quick server, and we're just providing an alternate means for transmitting data that might be shared among many different clients.
So you don't have to unicast replicate over the unicast quick channels. Okay. Now another thing.
That's correct.
Okay. So another thing I thought about, it might be hard for me to join the group because since the control channel tells me the S, G is, I may not know it. I could guess it, but I may not know it. So it would be hard for me to join, receive on encrypted data that I can't decrypt. You agree with that? Okay.
Yes.
Sandy at the mic?
Jeffrey.
Oh, that's Jeffrey. Yeah, I'm saying. Stig. Does Jeffrey go behind you?
Yeah, all right, okay. Yeah, Stig Vanas. So this sounds pretty cool. Just one thought I had is in the beer working group, they are looking at stuff where a source can send to certain clients without the client having to join first. So it's really, the membership is driven all by the source. And they're looking into using it for HTTP in some cases. So I think this could fit well within that. Of course, beer is not that much used yet, so you want to solve it for multicast in general.
Thank you.
Jeffrey from Juniper. Clients X each packet over unicast. Let's say you have 10,000 clients, and how does that scale?
Well, Right. It scales better than having 10,000 clients receiving the data over unicast altogether, right? I mean, you're gonna have to. We were thinking about not always echoing stuff, right? And you can use, but yeah, it would be somewhat a violation of quick.
Yeah, so in some sense, it still scales linearly, but the constant is a lot lower.
Is it fair to say the control plane is scaling the same, but it's the actual data packets are where you're getting the benefits of multicast?
Right, and because of the way that Quick handles ACKs, it's probably sublinear anyway, assuming that you're not losing a lot of packets. But yeah, I think this is one of those things where like we have ideas about how this is going to behave, but we're not really going to know until it's in practice and we're experimenting with it. So, but I mean, we're open to helpful analysis from other people as well, or thoughts on how this might work out.
Yeah, I actually don't know much about Quick, so my questions may be down. But I guess the one difference between this and 10,000 separate unicast sessions, or the differences there is that those 10,000 different sessions, they are separate ones. And here, this is one, all these acts are for the same session. Maybe it's not a problem, maybe it is, I just don't know.
Sticks up.
Yeah, Stigmanas, maybe a stupid question. I don't know Quick really, but do you have to send an ACK packet for each packet you ACK, or can you just ACK a lot of packets in one message? Can you
check? Yeah, go ahead.
Yeah, you can ACK one in many, but to come back to the general scaling questions, I would draw an analogy to Norm, the existing NAC-oriented reliable multicast spec. So this one talks about a single server scaling only in the tens of thousands for the reasons you were talking about. But we think we can distribute this over multiple servers in the same way we do other kinds of unicast distribution things. They'll have to be linked in some way because they all have to be able to handle ACKs for the multicast data. But that's the intent for how to scale it, and it should be compared to Quick unicast, not compared to like Flute, for example, for receiver agnostic. One thing that might be on the table if we get some deployment and sort of operational experience with this would be adding NAC frames to Quick if it turns out to be actually useful, but that's not part of this spec at this time. Also, like FEC frames, if it turns out to be useful, and maybe we can do more aggregation of NACs or of the ACKs or NACs or something. But right now, we're trying to be as vanilla as we can in a Quick context.
So I have a bunch of detailed questions. I want to let you finish your presentation, but actually, I think Jake answered half of the things, the broad statement I want to make. Have you guys looked at Norm? The answer is yes. It looks like you looked at NACs, because I was going to say, did you look at the early Van Jacobson work and the work that the Cisco's guys did in the 90s on PGM, pretty good multicast? These are all various forms of reliable multicast transports. And the questions about retrans, the high-level questions about retransmissions, repair neighborhoods, all that stuff. Are you trying to do that, avoid that? And you kind of said some of that, but I'll let you finish your presentation so I see how it works.
All right. Yeah, so speaking of retransmits, the retransmit could happen both. So you could have quick datagrams where you don't have retransmits. But if you have stream frames, the retransmit could happen over both multicast if enough clients or receivers lose the packet, right? Or you could individually retransmit them over the unicast channel as well.
Is it okay if I ask questions?
Sure.
Or you want to continue the presentation? I don't want to.
Yeah, what do you
guys-
recommend?
you guys
Do
make
you
the
think
call.
do you think you want to finish the presentation and then take questions, or is this helpful?
Because then we'll be we'll be educated more after you do it.
Sure. Okay.
Okay.
Let's finish quickly then. Yeah. Next slide then.
And just a note, Gory mentioned on the chat that Quick does not need to ACK every packet.
Right. Okay. Right, that's the problems we solve. But yes, as I said already, we want to get it into the browser. We're gonna have encryption for the packets. We have integrity checks like MB uses, as Jake said, so MB isn't, yeah. Right. Okay, I think I said most of that already. Right. The scalability is in the data and not the control plane. Yeah, okay. Right, the current state of the draft, we're already on version 3. We had some reviews internally and from Lucas and from Kyle. And for us at least, the current structure seems clear and the architecture. And we don't see any reasons that make it like impossible to actually get it deployed and use it, or things that are in violation of the security draft for multicast. So we got some feedback from the quick working group. Jake, do you want
to? Yeah, I mean, there weren't many people who commented. Lars had some positive things to say. I think Alex questioned whether it should happen in quick. You know, I think that can be discussed on the mailing list. Martin Duke said he found it technically interesting and would be doing a review, so I'm looking forward to that. You know, I expect that a lot of the people in Quick remain skeptical. Some of the offline comments I've had say that there's some skepticism that we will adequately solve the sort of origin security model for counting as non-mixed content in browsers. I would like to dig in more on that claim with people who believe it. Probably not in this forum, but we're trying to address that with the multicast security considerations, and we think that. So my opinion is that I think it can be addressed, but there are some differences. I think that they are minimal enough that they can be addressed, especially if we consider things like, so Apple talked about how they sort of treat a join of a multicast group as under the same rubric as sort of local discovery things as a potential privacy exposure that requires a user input. So this kind of thing, I think if it becomes more normalized, can contribute to protecting users against inappropriate privacy violations and I think that that's the main difference in terms of security. Although I'm not sure that I've fully captured everyone's objections to it, or that they fully thought it through, honestly, because a lot of them, I would say, maybe don't really want to think about it too hard yet. I think that will change if we can manage to get a decent deployment that does something, but it's going to not be in a browser first. It's going to have to be like in a fat client that's launched from a browser if it's going to address web video, for example. But we would like to do that in our, with our demo. Yeah, that's kind of where we're headed first, and then one day maybe into a browser.
Sure.
So this is Dino. So I'm getting a really strong gut feeling that this is a really good architecture. There's all these positive vibes going through my mind. So I think I'm really happy. And I'll explain why. You solve the source discovery problem because it's done at the source. That's really good. The fact that you're mixing unicast and multicast means if you wanted the unicast connections to go on an underlay and you wanted multicast to go on an overlay, this could happen with this architecture. That's really cool, at least for me, because I'm an overlay guy these days. Now I have a detailed question. So in PGM, there was NACs that came from the receivers when they saw a packet out of sequence, and the routers intermediate would build these lost neighborhoods. So when the packet was retransmitted, it would only go to the lost neighborhoods and not to the receivers that received it. So can you explain, I realize that if you want to retransmit a multicast packet that has been lost somewhere on some branch somewhere, that you may not be able to, you may or may not be able to identify where it was lost, and you could certainly retransmit on the unicast channels, which could be inefficient if the lost neighborhood was really large, right? So that's my question. What are you guys thinking about how to do this? And do you just retransmit on multicast and let the guys who got it drop the duplicates? Or because we did a lot of research with this on PGM, And we thought that the NAC neighborhood and having routers store state about lost messages was worthwhile. Turned out to be complicated and maybe an over optimization.
Yeah, I mean, yeah, we're not sure exactly how to do it yet. I think that's like one of the things.
Yeah,
in
I would say
operation.
we're not sure, but in terms of the architecture and the document, this would be a server implementation decision. So it's not going to be routers, I'll tell you that much. It's going to be endpoints. So it's going to be a server endpoint. And in a deployment model, we would expect probably to have servers co-located in a network and to maybe, like, I'm not going to give you this on the first pass, but one day, if this takes off, yeah, we'll have servers that are sort of dedicated to a particular network. And when there's loss that's correlated across that network, I would expect the servers to, as an optimization, to prefer to retransmit over multicast for that network. And if there was anybody who got it, they would be able, as a natural part of Quick, to discard repeats. That shouldn't be a problem. Yeah. But, that's sort of optimization for later. Yeah.
So what ended up happening in PGM is that we didn't want to have this router assist NAC thing. And so PGM turned out to be a reliable transport. And what happened was when there was any NAC that came back, it retransmitted down the tree. And what Jake just said is the receivers who got it just threw it away. It was much simpler and it was more end to end. So having said that, since this is really a reliable transport protocol, it should probably be done in the transport area. But the problem there is everybody hates multicast there. So we need good representation to do it. So, so maybe you teach us transport or we teach them multicast. I don't know. But, oh, okay, got it. So the plan is to do it in the Quick working group. Okay, got it.
Why don't you just finish? You got 2 slides, and then we'll open up for questions.
So the last 2 slides are basically about our implementation. So we started to implement it in Chromium, and we got all the frames, the new frames in, we got the transfer parameter in, and so on. The thing we're missing there is how to feed the packets we receive over multicast into the event loop of the regular Quick connection, basically. And that's a bit tricky in Chromium. So now we're thinking about, for the first demo, to instead use something like AIO Quick or something in Python, where it's much simpler to just feed the packets in, and you don't have all the overhead of Chromium. Of course, the goal is to get it into a browser, so eventually we will do it, hopefully in Chromium, but just for the first test like that. Yeah, also there were some issues with Web Transporter, but I think we're just going to skip over those for now and rather have the more multicast focused discussion, right? And that's it.
Yeah, Niels, Deutsche Telekom. First of all, kudos for doing the work, and I think you've got a really good approach here. In matter of transparency, I already provided some of the points to Jake offline. I think what would be interesting is to couple this also not just to a native multicast, but also to AMT, so that you have the opportunity to say, I will try first to join a multicast group once it's already set up, and then you try if there's an AMT relay, which is still better than unicasting it all the way. The other option, or the other point that came into my mind, is regarding retransmission. Maybe you should rethink about this, because if this is fundamentally for live events, from my so live TV, like Super Bowl or whatever, from our experience, there's only a really tiny time frame where you have the buffering and where it really makes sense to retransmit the data packets. In most of the cases, especially if you're further away from those retransmission servers, talking about 50, 60 milliseconds typically, then retransmission doesn't make sense, and then you don't have to actually think about retransmission. If you're talking about, and this was another use case, downloading files via multicast, so large downloads, etc., then of course it makes sense. Then you need those packages. But I think it's more to focus on what is really required for which use case.
Right. So we support both quick stream and quick datagrams. So if you use datagrams to send the data, you wouldn't get retransmits, right? So the application or the sender could choose whether to use datagrams or stream frames.
Okay.
But yeah,
Do
Jake.
you want to reply to that?
Sure. To also respond to that, we've been looking at like some of the mock work, the media over quick. We think that there's good synergy with the push approaches they're using there for rush and warp. And possibly for the R-Quick stuff or the quick R stuff that they're talking about. And the idea is as long as you're using server initiated streams, the whole stream has retransmits sort of built in, but you can still reset the stream and then that stream can be dropped. So you can have unreliable transmission at the sort of level of a frame or a segment if it times out. Some of the work that they're doing there we think will mesh well with this approach that we have here is basically the point. So I'd encourage you to read that to see if we need to do more than that, what that's doing.
Thanks. And the last remark to the acknowledgements, I think from a scaling perspective, especially if you scale up to those volumes that you have in mind or that you're wishing for, I think something like the TCP window size, where you only acknowledge certain packet windows, could actually ease up your life.
So we actually have a mechanic for bundling eggs, right? Where you wait for a time where like you don't have to egg immediately, but you can wait like a server set timeout before you have to like say, okay, I egg now, right? So we have that because yeah, in quick especially the egging is worse than in TCP, I think, just from the overhead. Yeah, Dino.
This is Dino. Regarding the comment you just made about live and retransmissions, I would just say don't have an option never to retransmit, and for live events use FEC, because FEC will correct most errors in real time. And just as a data point, the Solana blockchain uses FEC and UDP transmission. That blockchain does not use a reliable transport protocol, and it's working really well. And this is over like tens of thousands of nodes.
Which FEC do they use?
I don't know. I can let you know, but I don't know off the top of my head.
Okay, is it open source or is it some private?
It's absolutely open source. Yeah,
Okay.
yeah. And then my other question was, you seem to I don't think you're restricting it to one-to-many, but you described it as one-to-many. If you wanted to have a whiteboard session with 100 people drawing on a whiteboard, would this just be multiple instances of one-to-many, or is there any provision to do many-to-many in any specific way?
I mean, you need the unicast connection, right? So you would have to have like a central anchor point where.
Okay, so if you have one-to-many, you will have n-squared unicast connections, and that's a concern that Jeffrey made about. Okay,
Those
there's
wouldn't
no way
necessarily
around
be-
it by just throw resources at it. And
Dino, just going back, trying to understand your use case there, like 100 whiteboard sessions, those would be like, each one would be a multicast session.
I meant 100 participants in one whiteboard session.
But they're all writing on it.
Yes,
They're
so
all
they're all sources.
They're all sourcing.
They're all multicast sources. So
That could be an application solution where they just go to the source and then it goes down on a single tree.
Well, that's the way Zoom works today, and it's not decentralized, right? So this could provide decentralized solutions, right? So, okay, thanks.
All right.
One last question. This mixing of multicast and unicast, does that imply that if you wanted to do something like unicast bespoke advertising with a multicast stream, this would work well, or being able to mix in unicast stuff and multicast stuff?
Sure, the server could certainly decide if it wants to like send something specifically to that client over unicast that isn't supposed to be received by everybody else. Yep. All right, thank you.
All right. Thank you, Max. This is great.
Oh, all right.
So next up,
I want to share my screen.
yeah,
Ask the screen
I'm
share,
going to
maybe.
yes. I grant you. And put my hand down. Okay, so next up is Lauren. She's been working on the We've been speaking for the last few IETFs about the work she's been doing, and it's culminated with off-net sourcing and some recent enhancements with multicast menu.
Yeah, and as soon as my slides come up, it would.
Is slowly coming up.
Yeah, so I want to start by just talking through the stuff, the 2.5 components I have, and then hopefully we'll try some live demos and see how that goes. I saw the homework went out on the mailing list, but if anyone wants to download VLC4 that hasn't already and participate in the live demos, if you go to treatyend.net, there's a link on the top of the page for VLC4.
If there's anybody at Meet Echo, we're having a little trouble doing a screen share.
Maybe. I requested. Oh, do I really want to share my screen? Yes, I do. I would
All right.
like to share my
Never mind, Meet Echo. We're good.
entire screen. And allow.
There's Inception mode.
There we go. Awesome. Okay. So yeah, off-net sourcing and the multicast menu. Like I said, I have 2.5 components. Multicast menu and the off-net sourcing bit are the main stuff. And then I just want to talk about TJTB because I think it's a cool example of lowering the barrier of entry to streaming multicast. So multicast menu started off looking like this. And the main benefits of it were it lets you register and or add your multicast streams. Yeah. Better? There we go. Okay. So it lets you register and or add your multicast stream. So if you've got a multicast enabled network and you are putting your own stream out there, you can either manually report it, so typing in source, group, UDP port, and a description of it, or let multicast menu itself just kind of pick it up. Every night it goes through Internet 2 and Giant to look for multicast streams. Essentially, it's just hitting the looking glasses and running show multicast route detail to pick up any streams that are going through there. Alternatively, and this is where the off-net sourcing bit comes in, if you're not on a multicast enabled network, you can upload a file, like a video file, and have it translated. And there's an API to do this all programmatically. Of course, you need a way to manage what you've added. So changing like the stream information, title, description, category, and then also it's very easy to view the streams. It's much easier than, it's much more simple than the command line options that have been there in the past. We'd kind of have a direct option to open in VLC. We're still working on specifying that the AMT relay option when opening directly into VLC and verifying that the manual streams that are reported are actually exist. We do basic like, did you give an actual IPv4 address, but not really anything beyond that at this point. And then a protocol handler for opening directly from the browser would be nice. And then a student at TU Berlin recently kind of redid the UI, made it look a lot better. So we've got a thumbnail for each screen now, like I said, UI overhaul, and also the ability to sort streams by categories, liked, trending, editor's choice, and various genres. So the second component is off-net sourcing. So this is accomplished from a phone, and the phone jumps through a transport translator, which sends it to the multicast translator. So in words, so we're going from the sender and receiver from your phone, an app on your phone, to transport translator, sending it over UDP into the multicast translator, and that's where it actually enters a multicast enabled network for the first time. And then that multicast translator is obviously translating to multicast. Still working on various video encodings, and then the hope is eventually that this multicast live or this off-net sourcing app can also become an off-net receiving app. So you have some sort of AMT gateway implementation in the app, and then doing it for iOS as opposed to just Android. And then before we jump into demos, I just wanted to highlight TJTV. My old high school is one of the ones running an AMT relay, and it's just very easy to, if you have access to a multicast enabled network, set up streams. I've just got VLC sending them to the AMT relay. And actually the first demo is watching one of those streams. So for the demo, this is the kind of topology that we're working with. Multicast translator, AMT relay, and the box sending that TJTV are all on a multicast enabled network. And then the rest of the stuff isn't. We have our 3 imaginary people in blue, and all the stuff in green is infrastructure that actually exists. So I'm going to jump out of presentation mode and split my screen because I want to also see the terminal over there that's showing what's happening in the background. So the first demo is just viewing the TJTV streams at all. So going into multicast menu, where that TV is behind. Okay, so going into multicast menu, finding a stream you're interested in watching and opening it directly from VLC, saving, placing. It's just opening in VLC. So this is designed to simplify for an end user that might not know how to use a command line. We've got a stream. I have my laptop muted right now, but the audio comes through as well. So the flow that happened there was before any of this, I added, go back into full screen. I added the streams to TJTV, and I manually added an entry to multicast menu to tell you about the streams. And then we went from our laptop to multicast menu to get the information about the streams. And then we reached out to the AMT relay because here at IETF, we're sitting on a unicast only network. And the AMT relay was able to provide that TJTV source for us. Okay, here's where things get interesting. So this is the off-net sourcing bit. And this is the first of the 2 off-net sourcing capabilities where we're streaming from a file, so a pre-recorded video. If I didn't have access to a multicast enabled network, I could have done TJTV this way, just uploading the video. So going to multicast menu, add stream, and uploading a file, specifying some basic stream information to help people know what it is, and then selecting our file. And as soon as I hit submit here, it's going to buffer for a second. But when it goes through, you'll see that the translator is now receiving a UDP source in, and it's translating it as multicast. It picked a multicast group address for it, and then it pinged multicast menu's API to add it. And when we refresh the page here, we see that our video has picked up the source, our video in multicast menu has picked up the source in the group that was assigned to it. So if we go back over into the main page, we can again go through the process of opening in VLC. And this one takes us a couple seconds to load up, I've noticed. Should pop up. There we go. And we have our source that is streaming from multicast menu that I just uploaded. Okay, so the flow that happened for that one was that we, from our computer, we uploaded a file to multicast menu. Multicast menu sent that to the multicast translator to be translated as multicast, and then sent an API back to multicast menu to tell us about it. And then that same flow that happened before when we tried to view it. So the third and final demo, and the one that I think is pretty cool, is let's live stream this meeting. So we're not actually going to open the app because the video encoding is still messed up. But on my phone, I have an app. It's called HiVision Live. And is there a camera that shows? Anyway, it's on my phone. It's called HiVision Live. And all I did was type in the URL of this transport translator. And I'm going to start a stream, and I'll pop it up.
I can hold it.
Yeah, there you go.
The cameraman.
There you go. We got a cameraman. Okay, so
I broke it.
Okay. Hopefully that, okay. So we see that we have a second message here from our translator. Actually, before we do that, you see that we accepted an SRT source connection. That's what's coming from the phone. That's that first hop into the transport translator. And then we're forwarding on to our multicast translator to add to multicast menu. And we see we have this first item here, which is what we just added. There's no description available because we haven't added one yet, but there is the ability to crowdsource such a description. But if we want to open this in VLC, it's a lot of clicking to open in VLC, which is why we'd like to get that protocol handler to do it a little easier. But it does beat the command line for many, many users. Okay. There we go. And so now we're streaming, and like I said, audio comes through just fine. I just have my computer muted at the moment, but yeah. So most of this, let me get my slides back. Yes. And like I said, the goal is to get to a separate like multicast live app where it can be both a sender and receiver. But in the interim, HiVision Live, Android and iOS does the job perfectly fine.
Yeah, so just for those, you know, not following along, what Lauren's essentially built here is something that IETF hasn't done in about 15 to 20 years, which is stream an IETF over the Mboned, and better yet, it can be received by anybody on unicast only network. So, so we're getting IETF back into over being multicasted, and yes, and not only is it being multicasted, but it's being received by, it's being transported via multicast, but received by anybody on the internet, including unicast only, which is something that you know, even 20 years ago we couldn't do when these meetings were multicasted.
Yeah, with AMT. So I stopped the stream, so you can stop being cameraman.
All
And the part I didn't address is that if you hit stop stream, that all of the teardown is very automatic. So when it stops receiving translation here, it'll call back to multicast menu and say, hey, I'm not getting a source anymore. Please delete the entry so people aren't looking up stale sources. And for that last, the flow for that last was from a phone into our transport translator, which is just an AWS box sitting on the unicast regular internet. Then into multicast, into the multicast translator, back out as an API call. Yeah, so most of this is still pretty actively being developed. I had to-dos on each slide. So we're building up little by little, trying to pick and pull different bits of technology to push them all together to make this work. Yeah, that's what I've got.
Max. Sorry.
Oh, sorry.
Max
I'm failing
followed,
to get the Q6
he
section
followed
over.
instructions.
I just had a question about other source options. I mean, first of all, fantastic. This is very exciting. If I had something like an existing IP camera, can we pull that that stream as well somehow, set it as a destination into the translator and get that sourced?
Yeah, so that's not built in as like a easy clickable thing in multicast menu, but it's certainly very possible. Yes.
Yes, Max Franke. Great presentation, thanks. Clarifying question, I guess. So the app, the Hire TV app, sends it via unicast to the multicast translator? Right?
Yeah, so I've still got my slides, right?
Yep.
Okay. Yeah, so what's actually happening is it's sending, the HiVision app is using SRT, which is UDP based, but still has some server client aspects. And that's going into a transport translator, which is just taking that SRT UDP and changing it to regular UDP, and that's what's going into the multicast translator.
Okay, and then the multicast translator sends it out both via multicast, it translates to multicast and from there. Okay, all right.
Exactly. It
All
takes UDP, unicast, and
Okay.
out as multicast.
Thanks.
I just wanted to thank you for this presentation and say that I think this is the first time I've ever seen a live demo at IETF go down without a hitch. So really good job. That was fantastic.
I was very concerned.
I'm Jake. When you say regular UDP, you mean raw TS encoded inside the UDP, right? This is MPEG TS. That's
Yes, it's
okay.
MPEG TS. Yes.
Great, thanks.
Great job, Lauren. I just wanted to share some experience that I've seen not working because I used to work for a consulting company, and we were doing some consulting work at a large international insurance company, and they tried to live stream pretty much exactly in the same way that you did their all hands calls for the employees, on-site multicast, off-site through unicast. What you've done works, what they've done failed, and they had to reschedule the session.
Yeah, scalability is still a slight issue, more just because of like operational constraints. We've got a tiny AWS box and IP tables firewalls going into the multicast translator. But yeah, scalability is a little bit the next step.
But it worked. It worked.
Any other questions? Who's funding this?
You mean at the AMT level? Like who's paying for the AMT connections? Oh, the AWS translator is on my credit card right now. Yeah, he offered to fix it many months ago, and I just haven't gotten around to giving him that info yet.
I thought you said you're gonna help. I thought you were gonna say you're gonna help pay for it, and not you'll help remind me to pay for it.
Yeah. Yeah. Okay, how do I stop? Okay.
Great, that's pretty amazing work, and this is just for those without the background. This has been a multi-year project. It started with William Zhang at Thomas Jefferson High School about 5 years ago. He deployed the first AMT relay, and then 2.5 years ago, Lauren, 2.5, 3 years ago, Lauren picked up that work and has, she built the multicast menu and has extended and has enhanced, and we're up to off-net sourcing, which is something we've been talking about for years, and she was able to do this. So really, really impressive, and the work continues. Max, others have been collaborating, and Max is going to, at the end, talk about some work that his student is doing in collaboration with Lauren. So this is a great project, and it's exciting. And like I said, we're getting IETF back on the Mboned, and we're getting content on the Mboned, and there's lots of neat stuff. So I encourage folks, go visit the multicast menu, check this out. It works. It's real. When you receive that content, you're watching multicast streams over the Mboned. Something that, if we had 20 years ago, the world might be a different place, but it's pretty exciting. So next up is Eric. You are.
Hello, I am Eric from Vivo. We build software for multicasting Zoom and WebEx and other meetings. And what I want to talk briefly about is the history of some receivers and clients as a way to think about the past and potentially inform quick multicast and other considerations. So I thought it'd be useful to just give a very, very brief overview of some of the things that I experienced, and then some ideas about future implementation. So next slide. So this is some legacy receivers that you might have remembered. Starlight Networks back in 1996, bought by Pitchertel. And they did MPEG-1 multicast, and we built a web-based kiosk for them, very close to my heart, because I met my wife at a conference when we built out a little multicast kiosk using Starlight Networks. And then Progressive Networks, Real Player, again, another multicast receiver, QuickTime, Windows Media, VLC, of course. Enterprise companies like vBrick had other multicast receivers. And so this is thick software deployed by enterprises to receive multicast, typically within a very closed network, typically 1 to 12 channels, could be an IPTV scenario, could be just a all hands meeting type scenario, very kind of internal single domain controlled environment. But yeah, a range of multicast receiver software. Next slide. So then it evolved a bit more, moved into taking the Windows Media Player or Real Player as a control or an NSAPI plug into the browser. So wanted to get this multicast experience into the browser context so you could do interesting things about it. Then Flash with Flash animation movies and eventually video that then provided multicast capabilities from their Flash server. They had a concept called Fusion where they were blending peer-to-peer and traditional multicast and unicast failover. Same thing with Windows Media, had this concept of an NSC file where you could specify a unicast failover mechanism. So browser context was really important at this point where we want to do a lot of interactivity and other things in that browser and have it be a web experience and not just a thick client experience. Okay, next. So then what are we doing today? Well, in the context of trying to get multicast video to render inside of a browser, so here's a Video.js plugin in a browser joining a live stream, the way we have to do it now, and by we, I mean there's various companies that do enterprise video like Haivision, Kumu, vBrick, Kaltura, others. So these are companies that provide internal all-hands meetings and use cases for one-to-many video where they still want to utilize multicast in some way. So what they do is they have agent software, you could call it a multicast gateway, and they push that out to every single desktop and it becomes a web server. So they're running a local host web server on their PC. Mac ends up being this kind of strange Java implementation that's pretty tricky. But here you are listening on, for a local host HTTPS request from a browser. And meanwhile, these agents can be available. So when the browser makes this local HTTPS request for a service, it will then open up and join a multicast. So you could do a transport stream multicast, and then this agent would receive it. And transport stream happened to be pretty handy for HLS. So you could just take the transport stream and package it into HTTP HLS TLS to the browser. So that's how you get transport stream into HLS via a localhost browser web server into a local browser. And lots of security problems with that, but at least it solved the problem of getting multicast into the browser. So we're obviously really eager for quick multicast and better solutions to do this. One more thing and we're almost done. So last slide is what is Vivo doing? So we are actually building thick clients for all the different platforms. So there's a Zoom version, Google Meet version. We're using VP8, it's RTP, we use forward error correction. It has Chromium built into it, so we could do the interactivity with Chromium. It's a GStreamer code base with ULPFEC and it uses Qt for the wrapper. Lots of opportunity to make this much more simple with quick multicast. And since we have Chromium, maybe we can get to that very quickly, take out the GStreamer, make this just be one interactive experience, and that would definitely make our customers a lot happier. So last slide is the future, and Jake, eager to talk with you about it.
Great, thanks, Eric. I just had a question. 2 slides back in this deployment model where you've got a localhost server.
Yeah.
What do you do for mobile? Or do you have mobile support? Because there's like sandboxing issues with this model there, right?
Yeah, it doesn't support mobile. I mean, one option is to do a gateway in that local network, have that be on a Wi-Fi network and have
Yeah.
mobile devices just join HTTP unicast over Wi-Fi.
All right, thanks.
I have a, so I've heard over the years a lot of different use cases for multicast. This is the first time you've come up with a new use case. I believe you described it spouse discovery. You multicast spouse
Yes,
discovery.
yes, yes.
Multicast based. You actually got married as a result of multicast.
That's true. That's
Okay.
right. Yeah, I was definitely shy, but when my wife was at the conference, I had the gumption enough to go and say, check this demo out, and it worked as well. So I got lucky, and I've been married ever since. So I've been very lucky. That was a multicast join that's still successful. So I have lots of swag. If anyone wants T-shirts or mugs with multicast stuff, come on down. Any other questions? That's true. Yeah, there's no group sharing, key sharing, or anything like that possible in
Let's
that
just stick with
relationship.
spouse discovery.
So it is.
Yeah.
It is. And I guess that is the question. Yeah. Yeah. That's true. Yeah. There was no group activity in that one. Any other questions? All right. Thank you. Yeah. And again, if anyone's interested in shirts and mugs, I've got stuff for you.
Okay, Max, you're up.
All right, yeah. So this is just going to be quickly, basically.
You can take as much time as you want.
Yeah,
I
see.
You take us home.
Yeah, all right.
You've got 30
Yeah.
minutes.
Yeah, okay. I hope I don't need 30 minutes. But yeah, so this is like just some updates on, or like reporting on some of the student projects we're doing at TU Berlin related to multicast. So the first one is adding IPv6 support into the VRC implementation. So that's all the different ways. Jake did some testing at the last hackathon about the tunneling and so on. So since that worked, we're hoping it will work here as well. So we will have IPv4 and IPv6 and so on. It should be finished relatively soon. The project is going to be over in like 3 weeks. And the last thing to do basically is we are also looking where we're going to upstream it, hopefully. And we're also looking for deployments. So if anybody has an IPv6 capable AMT relay somewhere, or could enable IPv6 on a relay somewhere, that would be great in the Mboned. We're still looking to set our own relay at TU Berlin. So it would be the Deutsche Forschungsnetz, so DFN, which is not really Jean, but connected to Jean, and it's all a bit bureaucratic, and we're trying to figure it out, and hopefully we get a relay up soon as well. All right, next slide. Then the next student is implementing graceful failover for AMT, so make use of the L flag that's there, but as far as I understand it, not really used anywhere so far. And the idea is that the relay sets the L flag when it's about to shut down, or it knows that it's going to shut down soon for whatever reason, and the gateways can start discovery, and in that way keep the stream running and don't have any interruptions by the relay suddenly disappearing. This is part of a bachelor thesis, so the implementation should also be done in the near future. Okay, last slide.
Quick question.
Yes.
Is there an equivalent graceful restart on the client side? So the AMT relay can shut down the tunnel quicker when it goes away? So it doesn't have to time out? I'm worried about the relay encapsulating to where there's no client anymore. That's a good problem to solve.
Okay, thanks.
You know what I mean? No. If the client just drops off the air, if the AMT gateway drops off the air, and then the AMT relay still has the tunnel to it, it'll keep encapsulating to it until some timeout. So I just didn't want to send all the data on the network to no place, right? Right, I want it to happen sooner, so I was wondering if there's a sorry I'm going away sort of thing, when it's a graceful restart, not when it crashes or goes away.
Right.
then it would do it great. So that's the graceful mechanism. So you're saying, Jake, there's no need for that. Okay.
Yeah. But yeah, thanks for Jake for also coming up with that idea in a way, or like helping the student along as well. Right, and since it's a bachelor thesis, there has to be some scientific part, so it's going to include some measurements, hopefully, and how much time you save and so on. Yep.
Yeah, actually, there is a reason. If there's a if something goes away, maybe the relay can send a query sooner, so it can detect that no IGMP report is going to come back within 10 seconds. You could shut down the tunnel in 10 seconds instead of 3 minutes. That's useful.
Right. Yeah. Okay. All right. And the final one is basically what Lauren already talked about and shown is the update to the multicast menu. I guess the interesting part here is that on one hand, the pulling of the preview frames is going to do some measurements on how much resources that's going to take and so on. But the other thing is, how do you do like ranking for multicast streams, right? Because unlike Twitch or something, you don't have the viewer numbers, you don't know who's actually watching the stream. If you have something like multicast quick, of course, you would know that, but for the multicast menu especially, there's no good way of doing that. So he implemented something like cache, the same algorithm that's used for cache management, where you use the likes on the website to figure out which stream is relatively popular. But yeah, there might be future work on seeing like if there's, because also could be related to telemetry and so on. But if there's a good way to figure out like which multicast stream is actually popular and is actually getting watched by a lot of people. Okay, next slide. Yeah, so there's also the idea for a future project, but it's like a big idea, so we would need a bigger group for that. Maybe over the winter term is to try to get apt-get distribution with multicast implemented, right? So you would popular packets would get distributed over multicast if a lot of people are requesting them at the same time. Next slide. Yeah, and that's basically it. So if any of you have ideas for similar scope topics related to multicast or just any other collaborations you would want to do, we have a lot of students applying for thesis. We can't come up with enough ideas for interesting thesis. So yeah, we would be very happy if any of you have ideas or something like that. All right. Thanks. Lauren?
Yeah, with the trending streams, what is he tracking for trending streams? Just the like button?
Yes.
So would there be any value in tracking like how many people are actually clicking to open the stream as well? Because I mean that is a button that's clicked.
Right. I guess yes. The idea is then, or the issue I guess is, do you like weigh them differently? But yes, it's probably a good idea to like for future. I can tell. Yeah. Thanks. Yes, and you don't know, like if somebody joins from the console, from the command line, you also don't, I guess, wouldn't know.
Stigmanas, could you track how long people actually are watching? If people, just watched it for a few seconds, then they probably didn't care about it. If they watch a long time, they might really like it. Or
no, you can't.
Okay,
that's part of the issue.
I would imagine that you should be able to track, one, how many people click on the entry, and two, how many people could clicked on the launch in VLC. So at the very least, you know how many people actually did click to try to get it. But yeah, how long they were on.
Right. If they didn't use the command line, right?
Right.
For the second one, and that's why so far here's the like button, because that's like more a strong indication that's actually like something they want to watch and are interested in watching. But yeah, it's definitely like I think a bigger area where you can probably come up with some clever mechanism somewhere else that you could use. Yeah.
I think the only ones who are using the command line are like the people in this room. So
sure, yeah. Is anybody else using the multicast menu right now, right? Other than the people in this room. So
after this meeting, it'll be a lot.
Yeah. All right. Thanks a lot.
All right, thank you. So we do have a little bit of time, but that doesn't mean you can leave. So everybody, please, feet flat on the floor, eyes eyes forward, hands folded till the end. We have some time. Anybody have anything else they'd like to bring up and discuss? Jake, are you trying to leave or are you? Okay. Yes, t-shirts are here. I should say, like I mentioned, there's a Slack group that a lot of this activity is happening on. Reach out to me. I can get you added to the Slack group, or any of the others in this group, and we can add you and be part of the revolution. What's that? Okay, everyone. Thank you.
One of the big issues I had was like verifying the manual streams. Like, did someone give me a bogus stream? I think we'll probably repurpose the preview grabbing that's happening. Check if the stream actually exists. I mean, there's a certain amount of you can grab a preview.
That would be really valuable.
I'll probably.
Look at that.
Actually, that would be really valuable because that could prevent, in the past, there was like the issues with dead streams and like things, they go there and they never, remember SDR had hundreds of streams that were dead.
And it's hard because
They never got cleaned up.
an IP address, like make sure it's IP address. But yeah.
So I would really like to look at fixed cameras.
Yeah, it was good.
Panda cams? Pardon me? Panda cams?
Yeah, exactly.
Like traffic cams?
My garden right there.
The Chef Farm cam, remember Chef Farm?
Yes.
Wasn't that a cam on Namba at one point?
It was.
The barn?
I'd like to bring it back from the treehouse.
Now you know where to put it.
Well, I mean, she said some different set. I'll give you detail with her. I'll talk to you. I'll get contact with you. We talked about it. This really. Remember the flip camera?
Yes.
Before they canceled it, we had a flip live product that I was working with. And I was kicking one to don't kill the product. Turn it into an app. Then your margins go back, right? You're not having to build a single camera anymore. Everyone's going to have one in their hands. Turn it into an app and go. And then, they were trying to get the math. Yeah, I have a storied career. All
right, stay away. Because it turns out it was you all along.
Good point. I'm the master of shitty time.
Is there a medium by chance?
No.
I can't hear it. You were expecting engineers, so.
Yeah, I can't do that. Yes, I can do And then I'm thinking of the WebEx Live, WebEx Convention product I worked on. Tearing their stuff out.
Cool stuff.
It's fantastic. This is like one of the best meetings we've had in a long time. All of it's like, it's happening.
Yeah.
Holy shit.
You can see there's. So for the folks still on, the meeting's over. So thanks for coming and we'll see you in London.
Yeah, wait, let me just put that.
They are the node of the national security. So they run basically atmospheric satellites for atmospheric telemetry and weather telemetry data to research institutions. By default, we do this over satellite telemetry, but and they push out in real time. It's 150 meg streams that they're sending through. They usually use it by satellite, but you can imagine it's expensive. The second way to get it, the cheaper way to get it, is over the internet. And they use multicasts. So they connect to Geont. Geont is sure. And then two. Okay. Well, thank you. I was at Cisco for quite some time.
Okay, yeah.
I had a research project called Cisco WebEx. Wow. Had the whole thing running. We just couldn't get conditions around it. We had a PM that was all in. He got picked up by Google. New people come in and just afraid to do anything. Yeah, it's great. That's an example of a product I had that was canceled. I was working on Flip Flop. Remember the Flip?
Oh, yeah, the bot Flip.
They bought Flip, and then we had a new product coming out. It's called Flip Flop. We're doing the same thing that she did.
It's called Show and Share. Show and Share. Cisco took the Flip portal, actually offered it to the enterprise.
Oh, yeah, yeah.
They gave it away with every router.
Yeah.
He basically sucked the air supply out of all the competitors in the market. Cisco just gave it away. But anyway, Flip didn't have, I wish we could have had more people.
Well, that was the intent. Fine.